Hello and welcome. In this video, we will learn how to do numerical integrals with Fortran. In this case, we will apply composite Simpson's rule. This algorithm is the general purpose of integral quadrature, so you can use it for general case of the integral. So the first step is to integrate a function in one dimension, right? So the composite Simpson's rule divides the integral interval into several subdivisions. On each subdivision, the Simpson's rule with second order of polynomial is applied. So in this case, on each division, the Simpson's rule becomes like this. So this is the integral analytic, the analytic integral, the left hand side here, fx dx from a to c, and we approximate the result with the polynomial here px dx a to c, and because of the approximation here, we find the weight function of the polynomial on each point, on each data point. So in this case, we use second order of polynomial, which is r s multiplied with x plus t multiplied with x squared. So r, s, and t is unknown coefficient, so we need to find it. So in this second order polynomial, to find r, s, and t, we need at least 3 points here. So for example, here the line here resembles the function we want to integrate, and the dashed line resembles the second order of polynomial here. So we have to make sure that the polynomial on a must be equal to the value of the function at a, and also it applies on b and c. By using these three equations, and also by using the mid point here, the b equals to a plus c over 2, we will have this. This is the approximation. The integral on the left hand side is approximated by three weight function at 3 points: w1 pa, w2 pb, w3 p3, and it means we can use this part here, this part of the equation, by substituting the value of the polynomial p itself into the left hand side and compare to the result into the right hand side with the weight function, and we will have this result, the left hand side and the right hand side, and it produces three equation. How can it be three? Because we have r coefficient here in the right and the left hand side, and also s coefficient right and left, and the t coefficient and the right and left hand side of the equation. So from r we have w1 w2 w3 equals to c minus a, and from s we have aw1 bw2 cw3 equals to half c square and a square, and so on. And by doing substitution mechanism, we will have the solution here. W1 equals to W3, which is 1/6 C minus A, and W2 will be 2/3 C minus A. Then we have the final result of the Simpson's rule, and this is what we have: h over 3 multiplied with fa for fp plus fc. So basically h is c minus a divided by 2. In this case, we with the step size will be uniform here. H equals to b minus a, c minus b. So apply the composite scheme. Remember, this is the basic Simpson's rule. We don't do any composite rule yet. So to do the composite scheme or composite rule here, we split the integral into several parts. For example, the integral from a to c will be a to a plus d to a plus 2d, and so on until c minus d to c, right? So in this case, d is the we can say the step size or the width of the division. On each division, on each integral here, for example, we apply Simpson's rule as before here, and we have the final result of this. 2h over 3 multiplied with half fo. Fo is the x equals to xo, means a in this case. F2n is the last x, it will be c here. If we compare to the to the whole integral. And we have this simplified expression, right? So in this case, we define the x as this one. Fi equals to, Fi means f at x equals to xi. Xi means a plus I multiplied with h. I is equal to 0 to n. N is the number of division we want to perform, and the h itself, the step size, sorry, the step size of x is c minus a divided by 2n. Okay, so for example, we want to find the integral of the sin x from 0 to pi. Well, this is theoretically will be equal to 2, right? Sin x dx from 0 to pi equals to 2. So how do we do this in a Fortran program? Well, we have the composite, some composite Simpson's quadrature here. As usual, we have the program description at the beginning, and we have a is the lower bound of the integral, like it's similar to this one. A is the lower bound of the integral, and c is the upper bound of the integral. It is a number, and this is the number of the division, and h is the step size of the integrals, and the integral here, the integral variable, is the result of integral, and I is the integer for counting. So at the beginning, I define the lower and upper bound of the integral. As you can see, the upper bound is 2 multiplied with arcus sine of 1. So this is the intrinsic function in the Fortran compiler, and we have 15 subdivision. So we define the step size here of the x, and we do the calculation. So basically, this line, this line, it computes this part, because we have fa and fc here. A is the first, or fo, or xo equals to a here because it is the lower bound of the x, and the fx at I equals to 2n will be c. This is the upper bound, right? So this is fa plus fc and multiply with h over 3. So this part is basically doing this calculation. Okay, and the next part is here, the loop part here. We use the similar expression as we have here. The new integral will be the old integral. Remember, the integral is the variable to store the result, plus 2h over 3. 2h over 3. 2h over 3 is basically this part. We include into the calculation as well, and multiply with 2 here, multiply with f a I h. So the I will run from 1 to n minus 1 with step size of 2, right? And the next part is the next loop here. It will do this calculation, this part of calculation, and we have a similar expression here. Actually, it start from 2, and the I start from 2 here, and the step size is 2, and the final will be 2 multiplied with n minus 2 here. And after that we write the result here into the terminal, and we also include the function of fx here. Here we have the fx we want to solve is the sine x here. So maybe in the next if you have another function to solve, you can modify this line. Okay, that's it. That's I think that's the introduction of the Simpson quadrature, and in the next video we will learn how to modify the function and how to find the result of another integral of a function. So see you in the next video. Bye.